Life on Earth is dependent on water, therefore it is important for us to understand the nature of its interactions. Water molecules are deceptively simple polar entities that form a type of solvent for life. Because the oxygen atom is much more electronegative, the hydrogen side of the molecule has a partial positive charge, the oxygen side a negative charge. The molecule has polarity and will dissolve other polar molecules and ionic compounds. Partially positive hydrogens are attractive to partially negative oxygens on adjacent molecules. This accounts for the polarity of water, and each molecule can hydrogen bond to as many as 4 partners. Water that exhibits hydrogen bonding between its molecules results in 3 unique chemical behaviors: cohesion, adhesion, and surface tension. Cohesion is the attraction between like molecules. Adhesion is the attraction between unlike molecules, caused by the outer water molecules not having other water molecules to bond with on one side. Surface tension is the measure of how difficult it is to stretch or break the surface of a liquid. When impurities are added to the water, they can break down the internal hydrogen bonds, changing the adhesion and cohesion properties. Soaps have a polar end which bond with the water and a nonpolar end that does not. Thus, soaps almost completely destroy the hydrogen bonds in water solution. For the experiment, all you need is your laptop, pipette, soap, and water. The laptop and pipette can both be found in your small-scale chemistry kit. This experiment is not only extremely safe for students as it contains only harmless chemicals, but it is also safe for the environment because of the small amount of chemicals. The soapy water solution can be prepared by mixing a small amount of soap in with a small amount of water. Here is a list of the equipment you will need: the small-scale laptop with printed chemical race insert, distilled water, sodium chloride solution, sucrose solution, soap solution, plastic petri dish, paperclip, SSC thin stem pipettes, uniform strips of absorbent paper towels for cleanup, calculator, pen, and report sheet. To perform the experiment, the student will need to place 2 drops of clean water at the top of the lab here, and drops of soapy water on the laptop here, as well as salt water and sugar water. Be sure to use separate pipettes or clean the one you use each time to avoid contamination. It is important here that not too many drops of water are used. The purpose of the experiment is to show how the clean water drop will adhere to itself and the soapy water will spread out. The soapy water should spread enough that it does not make it to the bottom of the page, while the clean water will stay together and win. By limiting the amount of water used, the students will be sure to get the appropriate outcome. Also, in dropping the water, consistent pipette angle is necessary to obtain a consistent size drop of water. Any bubbles created in the soapy water should be popped using the end of the pipette and avoided if at all possible. Now it is time to perform the experiment by lifting the laptop off the table with the water droplets at the highest side. This can be done either very slowly or quickly, and the students can decide on their own technique or try several to see the effects. Performing the action quickly results in the clean and soapy water droplets rolling immediately, whereas slowly lifting it up, the soapy water will begin to move first while the clean water simply sits. Eventually, though, the soapy water will be fully spread out and not continue. Sometimes the experiment will not work correctly, but the majority of the time the clean water should win. The spray should be performed multiple times to ensure that the concepts are seen. Life on Earth is dependent on water. Therefore, it is important for us to understand the nature of its interactions. Even though water molecules seem so simple, it is also important to remember the fragile nature of the bonds. Life on Earth depends on the properties of water, and seeing as how in the natural form, water molecules when erased, we would not want to destroy them by adding unnecessary pollutants. Soap has the ability to release hydrogen bonding by running long lipid chains through the molecules, which break them apart. With the breakdown of the cohesive nature of water, it is clear that we need to envision more environmentally conscious chemical usage and waste treatment.